Hello, everyone, and thank you for joining me today. I am so excited to be part of AI Expo Africa again, and I really hope I get to see you all in person next year. I am Monica Livingston. I am Solution and Sales Lead for AI at Intel, and today I want to talk to you about AI in production. And by that, I mean AI deployments at scale, not specifically in the manufacturing space. I know sometimes the word production is associated with the manufacturing space, so I wanted to make sure that I discussed that right off the bat. So let me first address why this is an important topic. AI and analytics are applicable everywhere where we have an influx of data available. And that is essentially everywhere today. So we're getting more and more data from all of the sensors out there. And while many companies are dabbling in AI and they're experimenting, most AI projects don't make it to scale deployment. So my talk today is about the tools that are available to drive AI deployments at scale. But first, I'd like to start with examples of successful deployments. A great example is DC Water. This is a leading utility based in Washington, DC. And they were looking for a more efficient and a more accurate way to inspect their underground pipes for potential damage. DC Water turned to one of our partners, Wipro, to co-develop a solution called Pipe Sleuth, which uses deep learning and computer vision to automate the analysis of video footage from the pipes. With this solution, they were able to accelerate their time to AI while reducing the risk and the cost, all while improving the reliability of their customers, of their service to their customers. So I like this example for several reasons. First, the usage case is universal. Water companies around the globe have similar challenges. And second, it speaks to the globalization and accessibility of AI solutions. Here we have a solution developed in India by Wipro, deployed in the United States, and that can just as easily be deployed in Africa or anywhere else in the world. The next example that I'll talk about is another one with a global reach. Restaurants are everywhere. In this example, Burger King, a global fast food leader, has streamlined their development of a deep learning-based drive-through food recommender using Intel's Analytics Zoo Toolkit. Their goal was to improve their customer experience as the recommender was offering recommendations for what the customer might be interested in next, as well as, of course, increase sales. A customized recommendation was developed by considering two types of information. First was the guest order behavior, what the guest was actually ordering at the time. And the second was context information like the weather, the time, and the location. This recommender integrates Spark data processing and distributed MXNet training using Ray in a unified pipeline on a single Xeon cluster, therefore eliminating the overhead of a heterogeneous solution. And I like this example because the scale required demands cost optimizations. And what I mean by that is the following. When you have a proof of concept or an experiment, you don't have as much constraint on the cost of the solution because the cost will be small no matter what. And in the AI world, what that essentially translates to is we don't have to worry about the infrastructure that we run this on because it's a small deployment. But because fast food restaurants like Burger King have hundreds of locations, this AI solution needs to be deployed in hundreds of locations. So overspending on hardware would essentially multiply and ultimately make the solution cost prohibitive. The ROI just isn't there. So the takeaway here is when you're deploying at scale, optimizing your software and benchmarking your hardware to make sure that you're not overspeccing that hardware is extremely important. And one more example, HiHi is an AI technology leader in China. They are supplying medical institutions with high-performance AI-enabled medical imaging. These solutions then are capable of successfully diagnosing several diseases, COVID-19 being one of them. And this particular solution uses Intel Xeon Scalable processors with deep learning boost, as well as Intel optimized software like OpenVINO and the Intel distribution of Python. And again, The key here is using these optimizations in concert with your hardware infrastructure in order to make sure that you are optimizing your solution for cost. So I've given you a couple of examples of AI deployment at scale. And I wanted to start with those examples to show what the end state looks like. Not all companies are this far ahead on deploying AI, but most companies expect that AI will transform their company and their industry within 1 through 3 years. Deloitte publishes a really great report called The State of AI in the Enterprise. This is publicly available, and the chart shows that 61% of the respondents believe that AI will transform their industry within 3 years, and 75% believe that AI will transform their organization within 3 years. So let's look then at who is deploying AI. It shouldn't be surprising that cloud service providers and digital services companies are in the best position to take advantage of AI. They have available infrastructure and they have massive organizations for software as well as data. So not only that, but AI has enabled significant growth to their business. A simple example is recommender systems, which is one of the top 3 use cases for AI. These companies also pioneer their own frameworks like Google does with TensorFlow, and they're actively acquiring AI startups and publishing extensively. After cloud and digital services, we see investment really across all other industries. And of course, these industries are different in size, so AI investments may vary, but we see meaningful deployments and business impact from AI-based applications across all segments. So the point here is AI is transformative today. It might be in its infancy, it might be experiencing growing pains, but it is impactful today. So if at this point in our conversation, you're feeling overwhelmed, then maybe you're not adopting AI as quickly as it looks like the industry is adopting AI, we should have the build versus buy conversation. AI consumption in enterprise is in 2 categories. The first one is AI embedded in enterprise software. These are third-party applications that your company is already using for business processes like SaaS or SAP. And the second one is in-house projects built from the ground up. Now, allow me to go back to Deloitte and their survey for the additional data. They have found that AI adopters tend to buy more than they tend to build. 17%, in fact, say that they don't build any AI at all in-house. And I should actually also mention that the respondents of this survey, 100% of them are deploying AI. So they did not look at the part of the market that is not deploying AI. All of these folks that are providing these answers here have some level of AI deployment. And then you can see that a significant part of the population, 76% in fact, both buy and build depending on where they can gain a competitive differentiation and where existing solutions are already in the market. So the main point here is you don't have to build AI solutions from the ground up in order for your business to take advantage of AI. In fact, most enterprise software companies are actively including AI into their solutions and for specific functions like recommenders, like image, like vision. There are several companies in the market that already have ready-made customizable solutions. And if you remember back to the example we discussed with DC Water, using the pipe solution from Wipro, that this is exactly what buy and customize is. Wipro already had a pipe solution that they were then able to customize specifically for DC Water. Okay, so if you are taking the path of building some AI-based solutions in your house, in-house, you likely have run into some of these challenges. And I want to spend just a little bit of time to acknowledge them here because they need to be addressed in order for an AI project to be successful. And I'll start with hype. AI is such a buzzword today, and everybody wants to be part of it. But you don't need to solve every problem with AI. Make sure that AI is the best way to achieve your business outcome and that your return on investment meets your requirements. Business metrics still need to be met. The second one is data. So AI is extremely data hungry. And some rules of thumb for data needed to train a model are 12 months of data for forecasting and predictors and recommenders. If you're doing anything with image, you need about 1,000 images per class. And so it's important to have a broader data strategy beyond a single AI project, centralizing your data, removing silos, making data accessible at the edge or wherever the insights are needed. This should be part of a holistic company strategy. And likely the largest cost adder to any AI project is the cost of moving data. So moving data as little as possible within your solution is a game changer in terms of total cost of ownership. Now, because AI models are dependent on all of this data and on regular retraining, many business processes will need to change and to adapt. You can't just put an AI model out there and expect that it'll work forever and ever and ever. They decay. There's data drift. They need to continuously be retrained. And this generally requires a cross-company buy-in. So having an AI center of excellence or a champion for AI adoption within the company is generally very helpful. Your company also needs to keep up with new and changing regulations, ethics, liability process for the decisions that are made by AI systems. So generally having that AI center of excellence is extremely useful. And then there's also a significant skills gap with respect to AI functions. There's data science, ML engineering, app developing. Schools are scrambling to develop these curriculums for AI. And the good news is that a lot of these courses are available online for free. There's also several micro and nano degrees that are targeted specifically to these functions. These are degrees that are available for these AI specialties. And you've got companies like Udacity or Coursera that are an easy path to upskilling. So the questions that business leaders are asking and need to ask today is, what expertise do we have available in-house? Who do we need to hire? And what upskilling is needed for our existing workforce? Does everybody ultimately need some level of understanding of AI? But here's some very positive news for Africa. So I have this chart from Slashdata. They did a report for us on developer populations, and they allowed me to use this chart from their findings for this specific webinar. So what's really promising is to see that the developer population in Africa is increasing quickly. This data shows 14% growth over 2 quarters, which means that education and training is accessible. And that is extremely positive news, that we're not having these skill sets concentrated geographically as much. So great news for Africa here. Okay, so in the second part of our chat today, I want to talk about tools. And I'll be talking about tools that Intel is making available, but I do want to acknowledge that there are other tools out there so that you, the customer, the consumer, has ample choice in the market. And while this is getting a little bit deeper into the technical details, I promise I will make it clear why this is relevant to my business listeners today as well. So before we get into tools, I do want to address a question that I get asked every day, and that is, do I need new hardware for my AI solution? And infrastructure is a favorite soapbox of mine because there are so very few practitioners who understand how to optimize infrastructure for AI. And there are very few systems engineers who understand the AI workloads and how to get performance from AI. These are very rare breeds out there. And so people tend to throw the kitchen sink at an AI project. They are accruing significant technical debt because they're deploying more hardware than is needed. And then of course you end up with underutilized resources. And so this is one of the main reasons why POCs don't make it into production. They just end up being too expensive when you do the math on the type of infrastructure that, that you're being asked to purchase. So what my team spends a lot of time on is infrastructure optimization and model optimization with customers. And the general rule of thumb is, let's run your trained model. And this is mainly an inference conversation because a lot of times training is a little bit more of a point solution. But let's run your trained model on your existing infrastructure. Let's see what type of performance you get when you're running in your normal environment along your usual set of workloads. And if you're running in the cloud, benchmark across a different set of instances. And from that, you can assess whether the performance is good enough and whether you need more memory, more I/O bandwidth, more compute, but always benchmarking on your current environment sort of level sets what potential incremental resources you might need. So my second soapbox is optimizing software. Because the infrastructure is complex and you're trading off really cost, performance, latency, and bandwidth, software is an extremely powerful lever. We've seen performance improvements from 10x to 100x on the same hardware by just optimizing the software. And Intel offers an array of tools to do just that. And by the way, a majority of these are open sourced and free to use. So Intel optimizes all layers of system software infrastructure, from operation systems to applications. This includes libraries, industry frameworks, and tools. And the end goal is simple: offer tools to simplify and accelerate development of these end-to-end solutions as we're deploying them at scale. And as we talked about, AI is pervasive, which also means more models are being taken into production. This has given a rise to a high demand for ML ops. Time to solution, or how long it takes to complete a project and ultimately deploy it, is a key metric for companies. And this includes sourcing, labeling, and processing the data. And that can take several months. Experimenting with topologies, tuning hyperparameters, all of this is compute intensive, but it could also be time intensive. And then getting ready for inference at scale and integrating your model into a broader application, because AI generally is just part of the application, it's not the entirety of it. All of these steps are time consuming. And when you're also hit with the fact that there are disparate tools for all of these steps, so you have the added complexity of having to make sure that you have a good process to output your data and model at whatever stage it's at from one tool to another. And so this is really what drives the need for ML ops and a unified platform for AI modeling and deployment. And this is where that AI Center of Excellence that we talked about earlier really comes in handy. If you have that AI Center of Excellence, they can start standardizing and around some of these solutions for the entire company, so you're not reinventing the wheel every time. So there are several MLOps platforms that are emerging in the market, lots of good choices. Today, I'd like to introduce you to one of those choices. It's called Converge.io. This is a company that Intel acquired last year and continues to develop their end-to-end machine learning platform. They are deploying a cloud and enterprise customers alike. Converge includes several Intel tools and optimizations directly onto their platform, which again is why they're super interesting to me. So all of the software that you see here on this slide is included on the Converge platform. So your developers have easy access to all of these tools in one spot. And as new hardware is being launched, like Intel's upcoming discrete graphics product line and the Habana AI ASICs, that software too will be integrated directly into Converge, making it extremely easy to use that hardware and move models from one hardware to another if needed. Embedded into Converge are several Intel software solutions, but these are also available in the Intel One Container portal. So there's definitely different ways to consume these software offerings. So let's talk a couple of them, and I'd like to do that in the context of Intel OneAPI. So OneAPI is really two things. First, it's an industry-wide initiative based on standards and open specification. The second, Intel also has a product. It's a reference implementation, the OneAPI, Intel OneAPI toolkits. These are free to use. And so two things. industry standards, Intel products. So the premise here that it's a unified language and libraries to deliver full native code performance across a range of hardware, including CPUs, GPUs, FPGAs, and AI accelerators. The premise here is that you write code once and you could deploy it on different hardware targets. Of course, that requires some tuning, and there are tools that come in OneAPI for that specific tuning and optimization. But the base model, your code will be able to run on all of these different hardware architectures. And so Intel has, within OneAPI, has an AI and analytics toolkit, which includes many of the tools which I've shown you on 2 slides ago. And remember, I said you can consume these a couple of different ways. You can consume them in Converge. You can consume them individually through containers, or you could use them as part of the AI and analytics toolkit. The primary benefit, of course, of OneAPI is speeding up development and deployment cross architecture. Again, the point here is that a lot of times these models move from training to inference to retraining across several different types of architectures. And a lot of times it's maybe better to train on an accelerator, but then deploy on base infrastructure like a CPU. Or maybe you want to train on an accelerator and deploy on an FPGA. And so the benefits of this tool can really be realized in a lot of different ways. So now I want to talk about a tool called Analytics Zoo. And before I go on, again, I want to mention that Intel OneAPI, OpenVINO, and Analytics Zoo are all free to use. So Analytics Zoo is a unified analytics and AI platform for distributed TensorFlow, Keras, and PyTorch on Apache Spark and Ray. This allows us to scale to thousands of nodes and up to several terabytes of memory per node. So remember the Burger King example that we talked about at the beginning of our conversation? I now want to take you into the kitchen, so to speak, to show you how their solution was achieved. And for further reading, you can navigate to the Medium article that is linked at the bottom of this page for a lot more details on this specific solution. And again, this is all public information. So the goal of this model is to recommend menu items to customers as they're ordering. So when a customer first pulls up, their cart is empty. The recommender has to take into account things like time of day or weather or popular items in order to make the base recommendations, because they don't know the customer, they don't have any information about them particularly. Now, as items are added to the cart, the recommender has to adjust real time and use this new information to decide what to recommend next. So now, to make a relevant recommendation, the real-time user behavior and context needs to be taken into account. For example, you don't want to recommend ice cream on a cold winter day, or kids' meals at midnight, or soft drinks if there are already lots of other drinks in the cart. So the challenge here was to make the model as context aware as possible, as well as taking into account some real-time information like what the guest is actually actively ordering. So the model that was selected is called a transformer cross transformer, or TCrossT model. This model can explain the sequence of each order going through a sequence transformer, but it could also take context information into account through the context transformer. And then both of these transformers are then combined to latent cross to generate recommendations. And so now what does this have to do with Analytics Zoo? Well, the APIs in Analytics Zoo to build all of these transformers, the sequence transformer, the context transformer, and the TCrossT transformer are available, and they're free to use. And so this gives an example of just how much and how deep the availability is and the accessibility is for all of these AI resources. Now, let's talk about this example a little bit further. In a traditional approach to building recommendation pipelines, you would first set up two separate clusters, one for the big data processing, and you see that in the yarn cluster here in this diagram, all the way to the left. And the other is dedicated to deep learning, like, again, the GPU cluster with MXNet in this picture. The challenge here is that the structure introduces data transfer overhead. And remember, having to move data is very costly. And you also have to manage two separate workflows and two systems in production. To address these challenges, the solution that the engineering team in this case came up with is they build a recommendation system on top of Ray on Spark in Analytics Zoo. And this integrates Spark data processing and distributed MXNet training into a unified pipeline that runs onto a single Xeon cluster. This means that you are managing a unified workflow. You're not moving data as much because you're running on a single cluster, and you're not spending as much money on infrastructure. Again, single cluster. So why does Analytics Zoo matter here? Similar to my previous example, Ray on Spark is open sourced and available on Analytics Zoo. So you can literally fast track a recommender model and implementation by using free open source tools from Analytics Zoo. And just for posterity, let's look at how TCrossT models perform when compared to other models. Historical 12-month data was used. Remember when I told you in the past that, hey, about 12 months of data is what you need for recommenders and predictors. What they did is they used 11 months for training and then the last month for validation. So the goal of the model here in the offline training result is to predict the next best product for the guest to purchase. And you can see that the TCrossT model improves top 1 and top 3 accuracy over the baseline models. And then in the A/B testing result in a real world setting, the TCrossT model was run alongside Google Recommendation AI for 4 weeks. And what was evaluated was conversion rate and add-on sales. And again, you can see significant performance improvement by using the TCrossT model. Again, I just wanted to share this so you guys could see the performance, but also it is important to measure and have metrics in place for your AI systems. And do keep in mind that these systems do tend to degrade over time. Any AI models decays over time. And so you have to have a plan in place for maintaining that model and retraining and retesting. So metrics are incredibly important in this space. So there are several reasons why I wanted to go into details about this Burger King example. And I realize it might have been a little bit too technical. I apologize for that. Hopefully you stayed with me. So a lot of times examples are too high level and it's difficult to envision how anyone can achieve and apply them. And second, I wanted to demonstrate the availability of open source free APIs and tools that can really fast track that AI-based solution through development and deployment. It doesn't mean you don't have to test it. It doesn't mean it doesn't still have to meet all of your business metrics and processes, but there's a lot of tools out there that can help you fast track. Third, because restaurants exist everywhere on earth, food is universal. I love food. I wanted to demonstrate the universal applicability of these AI solutions. And finally, I want to drive home usability. It doesn't matter what country you're in, these tools and many more are available to you and accessible right now. And so where do we go from here? I think it's important to remember that AI is a disruptive technology and it will require process changes within your company, but you don't have to do everything in-house. There are many off-the-shelf solutions that are likely to fit your needs. And finally, if you do build in-house, there are many free open source resources like Analytics Zoo, like Intel OneAPI that are available for you to use. And finally, please join the other 2 Intel sessions. So Safia Boa will talk about Intel's vision for AI, and his talk includes 2 very special guests and a very special announcement. So please be sure to tune in or watch on demand. And the other session is from Walter Riviera, who will talk about federated learning. Now, this is a really interesting topic on how institutions, and by that think academia or hospitals, can pool their data together to train a model and of course improve the model because it's being trained on more data, but without actually making that data visible to each other, thereby preserving data privacy. So 2 very cool sessions for you to also check out. And finally, I would love to hear from you. Please feel free to connect with me and drop me a note. And I thank you for your time. I do hope to see you in person next year, and I wish you a fantastic conference.